This video is to give you a chance to practice on some of the concepts covered in the variables lesson. So take a moment, pause this video, and on a separate piece of paper, work out these problems, and then unpause the video for the review. Okay, so the first problem here, problems are asking you to evaluate the following expressions for x equals 3 and x equals 5. Remember that to evaluate means to find the numerical value. So find the numerical value. That is really important to know what that vocabulary means, because you will often see that on tests, quizzes, and so forth, where the directions will be evaluate, and you need to know what that means for you to do. So for the first problem, we would start with, we have x minus 2, and we are asked to evaluate that for x equals 3. So we would simply plug in the 3 for the x, and we'd have 3 minus 2, or 1. If x is equal to 5, then we would plug in the 5 for the x, and we would get 5 minus 2 is 3. The second problem is a little bit more complicated because it has two operations in it. But we'll go ahead and plug in 4x is equal to 3. So we have 4 times 3 plus 1. 4 times 3 is 12. And 12 plus 1 is 13. Doing the same for x is equal to 5. We have 4 times 5 plus 1. 4 times 5 is 20. And 20 plus 1 is 21. Notice that I am working top to bottom. Okay, I'm going to say that a lot. I was actually writing top to bottom on a lot of student work this week during my day job. So top to bottom, top to bottom, top to bottom. And it helps if someone's evaluating your work that you specify what you're plugging in for, and you don't just have scratch work with no labels on it. Next couple of problems have to do with using formulas. So how far will Stan run if he runs 5 mph? Okay, so that stands for miles per hour. And that's a good abbreviation to know if you got hung up on that problem because of that. Now you can maybe pause the video and say, I'd like to try that again. So 5 miles per hour for 2 hours. Now I did specify when I wrote the directions is to use the formula, because this is one of those concepts that a lot of students actually can do without thinking about the formula. You say, well, if it's 5 miles per hour for 2 hours, then that would be 10 miles. But what I want you to do with this one is to practice using the formula. So what I would tell my students to do is to write down what you know. You know that the rate here is 5 miles per hour, and actually write it off to the side. Rate is 5 miles per hour. And that would tell your teacher that you know what the rate is. The time in this problem is 2 hours. And the formula that we intend to use is distance equals rate times time. Now we'll go ahead and plug that in. So distance is equal to the rate, which is 5, times the time, which is 2, and 5 times 2 is 10, and the units on that would be miles. So I want to point out a couple of things that are really, really important as you start your algebra journey. Again, top to bottom workflow. This, I had a teacher in high school would tell me was list the givens. I actually had a teacher that made me do that. So list the givens. That lets your teacher know that you understand which numbers are going to get plugged in for which variables. State which formula that you are using. Be really explicit with that. Show the substitution. So if you look right here in my work, you can clearly see that the R was replaced with a 5 and the T was replaced by the 2. Just don't take it for granted that everybody shows that work or that everybody knows that. And then we clearly indicate our answer at the bottom of the work, and it helps if you want to box it in. Fourth problem, what is the area of a field with a length of 10 meters and a width of 15 meters? So same strategy here, okay? List the givens. So we know that the length is 10 meters. We know that the width is 15 meters, and the formula that we intend to use is area is equal to length times width. Okay, that tells the teacher or the person looking at your work a lot about what you know and understand at the outset of the problem, even if you end up making a mistake later on. We know that the length is 10 meters. We know that the width is 15 meters, and so the operation we'll do there is multiplication. 10 times 15 is 150, and the units on that is meters squared. Now, I don't really want to get into how we know that. We really want to cover a lesson on exponents first, which is coming up. So you might want to check that out if you're interested in where the units of meters squared actually come from. And then I'll go ahead and box that answer in so that it's very clear to whoever's looking at my work what is intended for the answer. So take a moment and look at your scratch work. If your scratch work is a little bit haphazard all over the place, take some time to clean it up and make the presentation of your work look good. Last of the practice problems, a parking lot has an area of 100 square meters. What are 3 possible values for the length and the width? So this is a little bit more stretching your understanding of what this might be, and it's going to tap into some really key ideas in algebra later on. So let's go ahead and we'll kind of do a sketch here. Okay, so here's my parking lot. We got some parking spaces. All right, and there we go. And we know that the area of that parking lot is 100 square meters. And what you're being asked is, what are some possible values for the length of the parking lot and the width of the parking lot? So you might have come up with a lot of different things here, okay? In fact, a concept that might come up here is how many possible answers could you have come up with? So you might have said it is possible for the length to be 10 meters and the width to be 10 meters, because 10 times 10 would give you an area of 100. You might say that the length was 20 meters and the width was 5 meters. Okay, and I want you to notice something there, that like what happened there was we doubled the length and we halved the width. But 20 times 5 would also give you the area of 100. You might do this. I don't know. We might do this. We might say that the length is 50 and the width is 2. Okay, now that would be a very oddly shaped parking lot, but I mean, technically it would work. You might have even said that the length was 100 meters and the width was 1 meter. Now somebody might say, well, that you can't make a parking lot that looks like that because nobody can drive around any of the other cars. And that also is going to tap into an idea later on in algebra about restrictions on what your values can be. So while 100 meters times 1 meter might work mathematically in the formula area equals length times width, it doesn't necessarily work practically in real life. Now there are other things that you might have picked for this. Okay, so now you might have gotten really creative, and I don't know, maybe, well, let's see, we'll get another like in here, 25 times 4. Okay, so but maybe you said 33 1/3 meters times 3 meters. Okay, so that gets into another key idea here, is that there actually might be infinite answers to this that you might have come up with. So I think this is an interesting problem. Again, you're just looking for the three possible values for the length and the width. As long as you came up with 3 things, then you answered the questions for that particular problem, and all is good. But it should provoke you to think a little bit about some of the interesting aspects of this problem and how the numbers might play out. What might happen if you looked at like all of the possible numbers? Would there be patterns to those numbers, and could you find different, I don't know, number combinations of numbers that would work for specific criteria? So there we go. Hopefully that went well, and I will see you in the next video. Don't forget, if you found this video helpful, to like and subscribe.